wanted to give you a, what do I do with it? Put it down somewhere. Oh, here it is. So, I keep getting asked, what does this cost? What does something like this cost? So, I got the idea for this because I saw this one day. They used to have these at Home Depot. I don't know if you remember, a couple years ago. Have you ever seen anything like this? No? So, a few years back, they had something like this at Home Depot. And I inquired about it because I thought it was a great idea. And to my disbelief, I quickly realized that I would never own one of these, at least not from this company. What do you think this cost? Oh, wow. You guys are all giving me high numbers. Yeah, actually, back then, the base model, which was the SP1000, it was only 1,000 watts. They wanted 14,600 for it. And I said, wait, what? Excuse me? Am I? Did I hear you right? So I was like, well, okay. Then I realized, okay, the solar panel was 1,000 watts. All right, but the inverter was actually a 4,000 watt inverter. You might wonder, how does that work, right? The reason is because they have batteries inside of the compartment. Batteries that power can be stored inside of them when you're not using them. That's the concept behind having batteries. Their batteries are fully charged, so when you need the power, it's there, but it's still producing power. You know what I'm saying? And so the inverter handles, this one is only 3,000 watts. I tried to get a 4,000 watt inverter to make it the equivalent, but they didn't have it in stock. All they had was this one. So I got this one because I wanted to be able to demonstrate something to you guys. Okay? So the 1,800 watt model, it was like closer to 25 grand. And I was just like, man, who's got that kind of money to just throw around, you know? Do you? So, I don't know. Anyways, what do you think this cost me? All this stuff. And if I had gotten the 4,000 watt model, it would be almost equivalent to this. Except that I haven't built the frame for it yet to put the panels on. But I can tell you what that would cost. So far, with what I have put into this, so far, with what I have put into this, what do you think it costs, what I have? 4,000 you said? You're close. Just in the electrical stuff, including the cables, this, all this stuff, not including the panel, it cost me $3,600. Okay? The box was $400. Okay? Seems like a lot, but it really isn't. It's not a lot of money to have power. Free power for the rest of your life. Okay? So, imagine if I would have gotten the 4,000 watt inverter, instead of $4,000, it would cost $4,200. Would you pay the $200 extra for 1,000 extra watts? I would. But I didn't feel like waiting because I didn't have time. All right, $4,200. Now what do the panels cost? I already told you what they cost per panel. $275, right? $275. And I'm getting 4 of them. This company was only giving you 3, the equivalent of 3. You could do 3, and it would be sufficient for this system. I was going to do 4 just because, you know, you never know. When you're out in the middle of nowhere, it's better to have a little more power on hand, on demand, rather than not enough. Because I mean, I know how we are, you know, especially if you're going to use this in a house. It's better to have a higher. So 275 times 4. I don't know. Someone have a calculator? 8 with 75, 300, 300, 600, so 2, 4, 6, 8, 800, it's 900, 8, 9, 10, 11, 1100 and, yeah, 1100. So 4,200 plus 1,100 is 5,300, right? So for $5,300, if you were to get 4 panels, and then the only thing left is a steel. How many of us here know how to weld? And I know how to weld, but, okay. How many of you know someone who knows how to weld? I mean, I know a lot of Navajos that know how to weld. How many people you think can weld something like this together? I could do this in an afternoon. I wasn't going to do it this way. I was going to do it a little differently, a little simpler. This is too complicated. All the welding, all the materials for the welding, probably another $450 with the paint. So really, you could have a decent system, and you don't have to do it on the metal. You could just put this in the house and put the panels on your roof, and then you don't have to worry about that. You know what I'm saying? Use your imagination, and you can do just about anything you want. So I'm just showing you this to give you an idea what you can pay for this firsthand or what it would cost you. You could pay for all of this literally just by working a job and buying it little at a time. You know what I'm saying? And that's very doable. It is. It really is. If you don't have a job right now, when you start working and you get a stable, consistent job, you'll see what I mean. You know, $5,500 really isn't that much money if you buy all the materials yourself and set it up yourself. This is not hard to do. Okay? I'm going to show you this afternoon how to put this together. Okay? Because that's what we're going to do. And I'm going to have a few of you work on building a frame so that we can set some of these panels up. And hopefully I can set it up and show it to you by this afternoon. If not, then either way, you will see how it goes together. And you're going to see, wow, this is a piece of cake. It really is. They make this super complicated sounding, but it's not. Okay? Anyways, so that's enough of that. Are there any questions in general?
What is that box called?
This one? Oh, this one. Okay, I didn't bring the actual box with me, but this is a charge controller. This particular brand is Morningstar. It's got a lot of features on it, this thing. You can control this with a computer. You can hook it up to a wireless network, and you can watch it anywhere in the world. You can, there's so many things. I'm not even going to get into it, but there's a lot you can do with this. This thing here, as I was explaining earlier, is of the utmost importance, especially if you're going to have an inverter. You can't go cheap on this for this system. Unlike with a solar panel and a pump, you can do a cheaper system, you know, $200 or less to buy something like this, to run a pump. But if you want to run this, you have to have something. This right here is about $95 or something like that. It was a lot. It seems like a lot, but trust me, you need it. Okay? So, as I explained earlier, it's important because of how it converts the energy from that. This will take every watt, every last watt, it will take it in, and it will convert it into usable power that the battery will take. Because if I hook up 4 panels directly to that battery, the battery will determine how much it will use, and it will only take what it can use based on the resistive load of the battery. Power factor correction, that's maximum power transfer, like I was telling you. It's a lot of math. You cannot take all of that and pump it in a battery. It's not going to happen. You need something like this to convert that into usable power to feed it into the battery, because you tell this, oh, my battery system is 24 volts or 48 volts, whatever. And so then it will take whatever you spit at it, and it will convert it into usable, okay? So that's why you need this. It's very important. And it will increase your efficiency by literally like 30%, 15 to 30, depending on how you set up the system. But literally, it will help you. And it will work best, especially when the sun is barely coming out. Okay? If this thing is barely detecting any power, the battery won't be able to use it if you have it hooked up direct. But if you have that power going into this, this will convert it into usable power and feed it to the battery, even if it's at a small current. But at least you're making use of the little bit of light that there is. Does that make sense? So, in other words, this is very important. Any other questions? Grant? No? Any questions? No? Are you sure? Yes.
No, I had one. Pump earlier, let's say, well, I'm going to use him, but say I've got a creek on my land, maybe 3 foot deep creek or so.
It's a good creek.
Like, what's the land looking at? So let's say I want to use that system. Did I just put that pump in the creek?
You don't want to just put it directly into the creek. Ideally, this is what I would do. So you have your creek. Let's just say that, so I'm going to draw 2 layouts. Okay? So first of all, as if you're looking down as a bird, looking down, straight down. Does that make sense? So this is what we call aerial. Aerial view. Okay? So in this case, you have your little stream. Okay? And let's just say you're anywhere on this stream, you want to pull water out. There are things that happen with that creek that cause the water table to change, if that makes sense. Sometimes that elevation is going to increase, sometimes it's going to decrease. One thing you never want to do is you never, ever, ever want to allow this thing to run dry, because this thing cools itself with water. Okay? So, what you want to do, the easiest solution is for you to build something next to the creek. Same with this lady that was asking me a question earlier about taking water out of the river. You literally want to build a holding tank underground next to the creek and divert creek water to it. Okay? For several reasons, especially in places like this. And it can happen even out east. There can be times where that creek will have so much sediment in it because of how fast the current is going through it. Okay? It happens everywhere. And so, looking at it from the side view, or horizontal, whatever, you have the ground, right? Ground level. And you have this tank. You can build it however you want. I would say at least 6 feet, 4 feet, whatever. You can line it with whatever you want. I would do concrete. It's just, I like concrete. You don't have to do concrete. You can do plastic lining. I wouldn't recommend it. You could do whatever. Use your imagination. You could line it with clay. Clay would work just as good. And so what you do is, let's say the creek is over here, right? This is a creek. And you have little fishies. Little fishies in your creek. Does that look like a fish? Maybe? Like the goldfish? So what you want to do is you want to create an area for water to go and dump into here. Why? Because now you have a controlled method. First of all, you're going to have your water at whatever height that is. It's like a trough. You know what I mean? And so then, whatever sediment is in the water, have you ever seen like the river in Shiprock and it looks all brown and nasty and you're like, and they tell you, get in, let's go swimming, and you're like, My dog doesn't care. My dog likes water no matter what. Remember the first day my dog came, he jumped in the river? Do you remember that? Did anybody see that? He didn't die. Anyways, so that sediment will come in here and the sediment will settle down here. Does that make sense? So the bigger your holding tank is, the more volume you have for sediment to settle, and the more volume you have for water. So what you want to do, let's just say this is 8 feet. 8 feet's a good distance from here to here. Doesn't have to be 8. I'm just arbitrary number. Yeah. So what you want to do then is you want to have a pump going down to say about 5 feet or 4.5 feet. You don't want the pump all the way at the bottom. Okay? You want it in the middle, and you could even, easiest thing to do, go to Dick's, go to Sportsman's Warehouse, or go to some place that sells these, they're like kayaking balls that you tug behind and you can hold stuff with them. They have little hooks on them. It's a float ball. Okay? It will float on the water, and you can tie a string to this pump. Because you see these pumps have loops where you can tie strings to it so that you can either pull them out of the well or so that you can hang it. Because you never want this sitting at the bottom of the creek or at the bottom of the irrigation ditch or river or whatever water source, pond, ever. You never want to do that because then it's going to try sucking up all this sediment and it's just going to be, you're going to pull your hair out cleaning that thing time after time after time after time. Does that make sense? So here you have this little ball floating in the water, and it's holding, imagine the ball. And it's got a little loop, and it's floating on the water. Okay? And then it's got a little string going on it from the hook down, and you have it tied to your pump. Does that make sense? And so it's holding your pump above the water. And that way, a lot of that sediment can settle. You have a controlled rate. So also, you have trees, debris, whatever, all kinds of stuff that's just going to keep going. If you do this at an angle, it will tend not to do that. Because what you do is, when you're doing this, if I explode this, you have this river here, right? If you make this culvert at an angle, feeding your tank, you also want to put a flap here so that what it does is as water goes and as trees, whatever's floating on that water, it tends to push it away so that it's not going to come around and go into your little holding tank. Some people like to put gates, whatever you want to do. Use your imagination just to keep debris from filling your pond. And even if debris gets in it that's floating, it's just going to float on top. You know what I mean? It's not going to, and whatever else will sink to the bottom. The reason is because there isn't going to be a high volume of water going this direction because you're only going to use a little bit of water at a time. So it's just going to be like a standing water. And so there isn't going to be a reason for anything floating down the river, any logs or whatever, to go that direction. Does that make sense? Maybe? I don't know. Does that answer your question a little bit?
Well, how deep would you dig past the water to get to the hole?
That would depend on you. You could dig it as deep as the creek is. If it's only like 3 feet, you could dig it as deep as that, or you could dig it, doesn't matter, just whatever you want to do. You just have to, and you'll have to play with it.
So I would think that if the creek goes down, then the water's not going to go down.
No. So that's why I was saying as deep as the creek is. And so, either way. You have any other questions? Any other questions? Do you have any questions? No? It's 11:45, guys. Okay? So, What else can I tell you about? So I'm just going to tell you. Well, I already pretty much told you.
Would you suggest trying to get used panels, used inverter? I know you can probably get a chance you're taking. With panels, most of them are like some are a lifetime, I guess. Some are like 20
No.
years.
Almost every panel manufacturer comes with a 25-year warranty. What does 25 years mean anyway? The warranty from the manufacturer states that after 25 years, that panel will produce at least 80% of its rated power. And here's another thing, is when that panel, okay, if you put this out right now outside and you hook up a voltage meter like that to it, which we will later today, it's going to pump out the electricity that it's telling you on the back. But if it was cold outside, like in the winter, do you think this thing will produce more electricity than in the summer when it's really hot? Or will it not produce electricity as much as in the summer when it's really hot? Pardon?
Depends on the sunlight.
So, in general, when the panel is cold, if it's cold outside, this panel will produce more power. Okay? So in the winter, these panels produce more power per square foot than they would in the summer because this panel is really hot.
Is that every panel or is that just
Every panel. That's the way photovoltaics work. So maximum what's called ooh. This is a word, it's insolation. Not insulation, like the stuff that's behind the wall, but insolation. Okay, solar. Okay? It's a concept for every 1 meter squared. Okay, that makes sense? A meter squared. For every meter squared, you can have a maximum of 1,000 watts. Okay? If these panels were 100% efficient, you could get that much out of it. But we aren't there, and I'm not sure if we ever will be. These panels are about 17 to 18%. In general, the most efficient panels are like 20 to 21, and they're going to pay a bunch of money for them. Efficient. In other words, 200 watts, 170 watts is what you would get out of a meter squared with the current technology that we have. Okay? So that depends on how they're fabricated. And it also depends on the elements that are used. These are predominantly silicone, but they use a lot of other materials to make them. So
would you buy
I would never buy a used panel unless it was so cheap. But I would rather buy, because as inexpensive as these are, I would never buy this used. I might buy an inverter used if I knew it still worked, and but that, no. Those are less than $1 a watt now. 275 for this, 360 watts, that's a steal. You cannot beat that. I don't care how used it is, I would rather buy this. It's worth every penny. Okay?
So how far would you put your panels away? Okay, let's say you didn't have a box.
Mm-hmm.
Say you got it in your house.
Okay.
Like, how much difference does it make in the length of the wire going from the panel to the?
So that is a good question, and I didn't talk about that, but if you get this little book, it'll tell you about what's called distance or voltage drop for a line, for cables, like for this cable. This cable is very fat, isn't it? Compared to this one, it's very thick. Okay, this is number 1. I think that's what he gave me. That's what I asked for, at least. It's 600 volt rated, blah, blah, blah. Yeah, number 1. So this is number 1, welding wire. This is like, I don't even know what this is. 14 gauge, I think. It looks like 14. Okay. Number 1, 14 all wire gauge. Which one can handle more electricity? This one can. Okay. If you are going farther away, there is a calculation that you can use, or there are charts you can look at that will tell you, depending on the voltage, how far can you go using this wire. I'll tell you what, if you're 100 feet away, you don't want to use 14 gauge wire to go. And if you're 200 feet away, even less, because by the time the power gets from where you're sending it from to this, you're not going to have 24 volts. You see, the wire has a lot of resistance inside of it. Electron mobility or electron flow inside of these copper conductors are slowing the electrons down. Okay? So the smaller the wire, the less distance it can travel. If you had this going 100 feet, you'd be all right. You could go a lot farther with this. So if you're going really far, you need to think about the voltage that you're sending and what size wire you have. Because the farther away, the bigger the wire you're going to need, and the more expensive it gets. And it's cheaper, by the way, to send power the higher the voltage. So 120 volts from the wall, you can go farther. 240, you can go even much farther because it's a higher voltage. That's why those power lines, that is why the utility company sends it at 7,200 to even hundreds of thousands of volts. Because the higher the voltage, the farther it'll go with a smaller wire. If you were to step that down to 120 watts or 120 volts, it wouldn't get anywhere. But see, that power plant is sending power all the way to California. Can you believe that? Because the voltage is so high. Okay?
So now in this box, or say we make a different way, not use the box.
Mm-hmm.
How far away from the house, coming out of that, does that matter also on the wire?
So you're depending on, so this inverter, I didn't mention this, only produces 120 volts AC. The input is 24 volts DC. Okay? These batteries are 24 volts each. So I have to wire the batteries in parallel to get them to stay at 24 volts. Now, 120 volts, you're going to need a good sized cable coming out of it if you're going to go a long distance away. If you're not, well, also 25 amps. There are what are called ampacity charts. Ampacity. Or tables, whatever. It's a table, and it shows you for 14 gauge, for 16 gauge, for 18 gauge, whatever. You can go this far, and it can carry this much current. And it depends on the type of cable. If it's THHN, if it's stranded like this is, or, there's so many different types of cables. And it depends on the insulation of the cable, too. So this is way more information, but there are a lot of things you have to take into account. You know what I mean? So just to give you an idea, I would have to know a distance and how much power if you're only doing 25 amps, in AC, 10 gauge wire is rated for 30 amps per the NEC, which is the National Electrical Code. And that's what everybody uses, even people in other parts of the world. Okay? If you're going to engineering school or any electrical school or trade, most places in the world will use the National Electrical Code. And it doesn't say that in here, but yes, this is 14 gauge. So 10 gauge is much thicker than this. So that is rated for 30 amps, but only for so long. So if you're going a greater distance, I might even increase it to an 8 gauge.